The topic of this video is graphing exponential functions. Let's look at a problem. Graph f of x equals 3 to the x power by hand by completing the table and plotting the points. Okay, so the first thing we're going to do is we're going to verify that this is an exponential function by comparing it to the definition. We have f of x equals capital C times a to the x power, and we're going to compare that to what we're graphing, which is f of x equals 3 to the x power. The first thing you might notice is there's a part missing here. So what is the only number that we can multiply 3 to the x by without changing its value? That would be 1. We could rewrite our function as 1 times 3 to the x. And what that tells me is that my initial value for my function is 1, and the growth factor is 3. Both of these things are going to be important, as we will see. The initial value is 1, and the growth factor is 3. Okay, more information on that later. Let's go ahead and create the graph by plotting points. We've been given the values of x. They are the integers from -2 to 2 inclusive, and we just have to plug them in one at a time. Remember that f of x is the same thing as y, so if we want, we can write y equals 3 to the x power. Now, if x is equal to -2, then y equals 3 to the -2 power, which, using our knowledge of intermediate algebra, can be rewritten as 1 over 3 to the +2 power, which is the fraction 1/9. As a decimal, 1/9 is equal to 0.1 repeating. If you put that in a calculator, you're going to see it's 0.111111. The ones go forever. Let's try our next value of x. If x equals -1, then y equals 3 to the -1 power, which is 1 over 3 to the +1 power, which is 1/3. And 1/3 as a decimal is 0.3 repeating. Next x value. If x equals 0, then y equals 3 to the 0 power. The intermediate algebra rule that will help us here is that any non-zero number raised to the 0 power equals 1. So this is 1. We now have our first connection to the work we did before starting this problem. The initial value for this problem was 1. We found that capital C was equal to 1. What that tells me is that when my input x is 0, the starting value, or the initial value, is 1, and this is consistent with our table. Now, as we find these final two values of y, I don't feel that any algebra is necessary. This is actually very easy. If we replace x with 1, 3 to the first power would tell me y equals 3, and 3 to the second power tells me that y equals 9. And this is where the growth factor comes into play. The growth factor, a, for this problem was 3. What that tells me is that as each value of x increments 1 unit at a time, the value of y is multiplied by 3. 1 times 3 is 3, 3 times 3 is 9. This also works in reverse if you want to go up the table. Each time you decrease x by 1, you're dividing by 3 as you move up the table. So 9 divided by 3 is 3, 3 divided by 3 is 1, 1 divided by 3 is the fraction 1/3, and if you take the fraction 1/3 and you divide it by 3, it gives you the fraction 1/9. So we can see that understanding the definition helps us to better understand how to solve problems. All right, now all we have to do is plot all of these points. So let's start with the nice and easy ones, the ones that have integers. 2, 9. All right, so that's going to go right about here. 1, 3, that will be here. 0, 1, that's a y-intercept because it is an x-coordinate of 0, and that will go here. -1, 1/3, which is approximately the decimal 0.3. So I'm going to approximate that location here. And -2, 1/9, which is approximately the decimal 0.1. That's even closer to the x-axis. And we remember that every exponential function has a horizontal asymptote sitting on top of the x-axis. I should be very specific with my language. Any exponential function that matches the definition, f of x equals capital C times 3 to the x power, will have a horizontal asymptote of the x-axis. So this tells us how to connect our dots together. These blue dots will all get connected, and they're not going to go below the x-axis because they're going to forever approach but never reach the x-axis. And we have to be careful when we create our graph to reflect that. All right, there we go. We've now created our graph of f of x equals 3 to the x. And if you've ever heard somebody use the expression, it grew exponentially, this is the mathematical definition of exponential growth. As you can see, it rises very, very sharply.